Welcome to Unreal Gems. In this video, we are going to take a look at the Anim Dynamics node. It is a more performant node compared to the rigid body animation node, and we are going to use it to give some physics to Citrine's Earings. Okay, so once we have seen urban nodes, the next natural step is taking a look at Anim Dynamics. That remember that they were animation nodes that were used also to simulate parts of a character in a physical manner. Remember that I told you that they were very lightweight, but the look that you can achieve is a little worse than with rigid body animation nodes. So the advantage is that they are more performant, but the simulation suffers. Still, it is kind of nice for a mobile game or where you need a lot of performance. They are gonna work perfectly. This is the node that you are going to be using, which again it's called Anim Dynamics, and that we will use on the animation graph. And remember that you can turn them on or off using LODs or other animation settings, which will come in handy. We have to also remember that they do not need a physics asset, so we are not going to be using the FAT editor, the physics asset editor, because we are going to work only on the animation graph, which is where we can set up the Anim Dynamics nodes. And also remember too that you cannot collide with other rigid bodies when using the Anim Dynamics nodes. They live on their own and they collide only with themselves, and if you have other objects that make use of the physics assets and rigid bodies, you are not going to be able to make them interact with Anim Dynamics nodes. Okay, so we are back in the engine, and as I mentioned before, we are going to use Anim Dynamics to give those earrings a more dynamic look with physical simulation, because right now they look like a pair of sticks. They are straight and they don't do anything, and we want them to look better and have a little movement. So let's go ahead and open up the animation blueprint, and in the animation blueprint we have the anim graph. If it is not opened for you, go ahead and in animation graphs double click on it and it will open up this editor. Again, we have the locomotion with the catched pose, which is kind of a variable that we can reuse, and we are making some room to get our Anim Dynamics node and check context sensitive, because if not, it will not find it. It needs a component space pose. So we need to convert it from local to component. That is why it is not by default popping up. Once we have it, we can go ahead and organize the graph, because right now it is a mess. Let's make some room in the middle and let's align everything so it looks nice. And we can do it with the right mouse button and alignment, distribute horizontally to make everything equidistant, and then we can press Q to align everything, and the graph will look really nice in my opinion. We can compile so we can see the Anim Dynamics node options and so on and so forth. We can see that we are injecting between the locomotion steps or physical simulation that is then going to be fed to the main states and the output pose finally. So right now we are ready to start using the Anim Dynamics node. If you click on it, you are going to see the details on the right. So we can go ahead and activate preview live, show linear limits, angular limits. Those are only debugging options. If you would have planar limits or spherical limits, you would also activate that. But for now, it is enough, and we are going to start setting the node up. So first things first, we need to select the bone that we are going to simulate. In this case, we are looking for the left earring, so we can write earring and look for the correct bone, which is L earring 1. we go ahead and we click on it, that is going to make the bone be simulated. And if we want to, we can use a chain, but for now we are not. You would have to activate that checkbox and select the end of the chain. But for now, we are not going to do that. In the end, we will have an example and we will dive deeper on that topic. For now, let's go ahead and see what the Anim Dynamics node preview looks like. So if we rotate our character and our viewport and we get closer, you are going to see some boxes pop up. With those boxes, you're going to be able to simulate. You can select the box with the left mouse button, press F to center the viewport. Next, we need to make the bones smaller because right now we cannot see anything. Okay, perfect. Now we can see the box. And for now, if you press play, it is going to do nothing because we haven't set up anything at all. So you need to set up the body definitions. The first thing is the box stance. We are going to make it smaller. You are going to see that maybe this is not ideal, but I want you to see an example of everything. Here, as you can see, when we change the box stance, the box is getting smaller. And be careful here because we don't follow the same guidelines as in the rigid body tutorial, because here boxes do not have to represent the extents of the physical object that they are simulating. Here they represent more like the mass of the object and the simulation size. So for example, bigger objects will have more inertia and less twitchiness. With the box stance, you are controlling the behavior and the physical parameters of the object and not only the collision, because here, remember, there are no collisions. Remember, when changing parameters in Anim Dynamics, that a little goes a long way. So here, small changes in the box stance or the local joint offset can mean big changes in the simulation. So be careful because it breaks easily. So you have to finesse it a little bit, but with my advice, I think you will have no problems. So right now we need to preview the simulation with an animation, and we need to set up the local joint offsets, because if not, there will be no simulation. For that, we can use the Anim Preview editor and activate the should move variable so the character starts walking. With the movement, we can go ahead and set up the local joint offset. Here we want to create an offset from the starting point of the simulation so that the box can have that offset and it starts swinging and being physically animated. So for that, the usual is displacing it in the direction of the length of the bone, so the X axis. So we use 1.0 in the x-axis and a little to the side so it is straight in the y-axis, so minus 0.16. With that, you're going to see a green line that extends from the point of the bone depending on how much we have displaced the local joint offset. This is the key of the simulation in tandem with the linear limits and the angular limits. For now, since we have no angular or linear limits, we are still not seeing much physical simulation, but once we update those limits, you are going to see the object start to be simulated. So for now, we are going to start with the angular constraint. We are going to leave it at angular. We could use a cone and set the cone angle, but I prefer having control of the twist axis, which in this case we are going to leave in the x-axis, and we are going to set the minimum angular limits, which are going to be minus 45, and the maximum angular limits, which are going to be 45 and 45. We are using the Y and Z axis because those represent the forward and backward direction and the side-to-side direction. As you can see now that we have compiled and the limits have appeared on the viewport. As you can see, it is going to be able to rock back and forth with the green cone and side to side with the blue cone. So those correspond to the different axes. For now, we are having trouble because the simulation is way too twitchy, but we will fix all of this, changing some settings and using a couple of tricks that we also have at our disposal here, like for example, linear damping, angular damping, and so on and so forth. If you go to advanced, you are going to find several useful options, like for example, the iterations of the solver. But right now we are concerned with the angular damping override. We want to set it to the max, so 1. And we also may want linear damping. But remember that even when using linear and angular damping, we can have trouble because of the box size. Here, remember that the box size is really small. And also, another thing worth mentioning is that the local joint offset, if it is too close, you are going to get lots of angular movement and twitchiness. So, for example, if we would use 0.1 in the local joint offset, you would see even more twitchiness and more problems. Again, we can go back to our knowledge from the rigid body simulations and we can go ahead and use the component linear acceleration clamp to try to make the simulation more controlled using 4000, trying to limit the forces that come from world space to component space, because remember we need to inherit the character acceleration and velocity, but even with this, you're going to see that there comes a point where it is more important to properly set the boxed stance and the local joint offsets, because component linear acceleration scale, velocity scale, and clamp have less impact here than they did in the rigid body setups. So remember that, because this is not going to save you, and you will see now when we play, you are going to see that our problems are not fixed. Even when activating linear damping and using the maximum amount, which is going to be again 1, if we press play, you can see still that there is a lot of twitchiness here and everything is rotating too much. So lots of problems here. As I mentioned before, box stands and local joint offsets are extremely important. You're going to see that just increasing the box stands, multiplying them by 2, keeping the elongated shape, are going to fix our problems. So it is quite amazing if you know how to use those two parameters, how easily you can fix some errors. Right now you can see that the simulation would be useful. Nothing is rotating too much and we are getting the movement more or less that we want. It is not perfect, but as you can see, with a small detail like that, everything got fixed. Let's see it now in game. It is looking great, but I think we can improve it a little bit, because right now when you jump, the forces, the down forces, as you can see, are not affecting our earrings. So we want to fix that. Here, as you can see, the simulation is way worse. If we would use rigid bodies for that, they would already have that downforce applied to them properly and everything would work correctly. But let's go ahead and use the linear limits. So we are going to use here linear constraints, and since the earring would fall as soon as the simulation would start because of gravity, we need a linear spring, so it pushes it back up. So we are going to use 800 and see how it looks. We are going to turn down the angular damping to 0.7 because right now everything is more stable, and turn up to 1 the linear acceleration scale and the linear velocity scale, so that we get every ounce of force that we can from the world space movement of the character. With that, you can see that everything is still looking good. And now when you go down, the earring also drops down. But I think that the linear spring constant is way too much because it was killing the angular movement, not only the linear movement. Let's go up a little bit and let's test it out so that we get the right amount of force, the right amount of spring. I think we can go up to 700 and leave it there because we still are getting some movement, some angular movement and linear movement. And let's now see it in game and see how it looks. When we jump, we should expect now the earring to drop, and when we are walking, you can see that also it drops a little bit. So I think right now it is looking better, but as I mentioned before, you are going to see now the big impact that the box stands and the local joint offsets have, because we are going to prepare the right earring and we are going to use different settings, and you are going to see how we get inertia and down forces with those settings that we are not getting here and that are making our earring static. Okay, so let's go back to our anim graph, and this time we are going to add a second node, which is going to be the right earring, and we are going to use settings that make it, as I mentioned before, have more inertia, more forces, and behave, in my opinion, in a better way. So let's go ahead and look for Anim Dynamics again. This time we are already working in component space, so no need to convert. And now we just need to tell the Anim Dynamics node that we want the previews and the limits. We need to tell it the proper bone. This time is our earring 1. And again, we need to set the box stands. This time we are going to make it way bigger, so 20, 10, 10. And the local joint offset is going to be similar, but since we are on the other side, we are going to switch the sign on the y-axis. If we go bigger with the local joint offsets, it's going to make the angular rotation smoother. If we would go like really small numbers, like 0.1, remember, the angle rotation is going to be way more apparent and twitchy, and just be careful with that because it is really important. I'm again setting a linear limit, so this time 0.5, like last time, same, and the angular limits, which are going to be minus 45, 45 in the y-axis and minus 45, 45 in the z-axis. Linear spring constant, let's keep it at 800 for now. And this time we are going to play with gravity scale. So since we are making the object way bigger, it is going to be kind of stuck. So we are going to need to play with the gravity scale, but first let's see what happens when you don't. Again, we are going to use 1.0 in linear damping and 0.7 in angular damping. Component linear acceleration scale, 1 on all axes, and same for velocity scale, because we want all of the forces that are available to us and to influence our character. So again, let's compile. You can now see the limits and we can play and see what the result is. Right now, as you can see, the earring is not moving a whole lot. And that's the reason I told you before that we are going to need to play with gravity scale. Because the object is so big now, it has a lot of mass and the movement is not making it move. So if we scale the gravity by 10, you can now see a small movement and it is more or less properly working. It is maybe too smooth, but let's check it in game because sometimes the results are way different because the forces here can be bigger. So you can see now the right earring moving, but it is way more smooth than the other one. And when you jump, as you can see, it gets some forces and inertia, and it never stops moving until it loses all of the energy that it has to dissipate. So as you can see right now, it is way, in my opinion, more pleasing to the eye and it is not as twitchy, but you still get all of that sweet movement that you want on those character objects. So right now, as you can see, everything is looking great. The hair, the earrings, I'm really liking the final result. Here you can see the importance of the box stands and the local joint offsets. If you set them up properly, having in mind that it has nothing to do with the real size of the object that you are simulating, you are going to get great results. Another concern may be the hair clipping with the earrings or the head clipping with the earrings. For that, we are going to activate the spherical limit on the left one and maybe on the right one, but let's start with the left and try to make it not clip with the hair. And once we have that, we can go down to the limits section. The planar limit we are going to turn off and we are going to use spherical limits. Press the add button and extend the drop down. And now we can go ahead and select the driving bone. It could be the head, or in this case, since we are trying not to go too far from the current bone position, we're going to use the same bone. Next, we have the local offset and the limit type, which can be outer or inner, and the radius. For now, you are not going to see anything because the limit radius is 0, but we are now going to see when we activate a bigger radius that you can debug how the spherical limit works. So for now it is too big, so let's go to 1 or 1.5, which is more in line with what we want. We don't want to give it a lot of leeway. We want it to stay put and close to the original position. So for now, let's go with 1.5. And now you can use an offset if you want, like for example, for it to go down, like here, we have a local joint offset that goes down. So we want the sphere local offset to also go down. 10 is way too much, as expected, but you can debug with the viewport. And now it is more or less where we want it to, with 1. And the limit radius we are going to turn down so it cannot go further away from that. Right now the limit type is outer, but we want it to stay inside. So with this setting it would not enter the sphere, but we want it to stay inside the sphere. So we change it to inner, and right now we should have less leeway with the earring, but as you can see, it can cause some problems because we are trying to limit it and sometimes it can go crazy. So let's go ahead and make it a little smoother with box stands 422. And now if you play it, it looks good. So let's go ahead now and check with the hair in game and see how it is looking. For now, it should not go as far, but as you can see, it is still clipping with the hair. So we need to be more aggressive, because for now it is not properly working. So let's go ahead and go down to the spherical limits and just the limit radius, make it maybe a little smaller, or play with the local offset and make it a little smaller too. And maybe displacing it a little to the side, it may also help. But for now, it should not go as far because we took down the limits. It is looking better, still clipping a little bit. So let's go ahead and displace it to the side, as I mentioned before, because that will probably help with it not clipping with the hair. So let's go back to the animation graph. And in the animation graph, we are going to displace a little bit to the side the sphere. So it makes the earring go a little to the right. So let's go ahead and input in the y-axis 0.5, although I think this is wrong, but let's try it out. Yep, it's the opposite way. So I need minus 0.5, wrong again. I'm having trouble writing today. Okay, perfect, minus 0.5. And now it should stay to the right instead of moving as far to the left. So in this case, let's go ahead and test it in game. And as you can see, it right now does not clip as much. It stays to the right of the hair. So it may be a little extreme and it would probably not be necessary, but I just wanted you to see how it works. And right now we are going to use a planar limit instead of a spherical limit in the right earring, and we are making it not clip with the face or the neck. So this time we are going to use a different driving bone. It is going to be the head, because if you now select the earring 1, it's going to move with the plane is going to move with the bone. And here we wanted to stay with the head and protect the face or the neck from clipping. So we are choosing the head bone, which is in the middle of the head. And now we are going to use the plane transform to displace the plane. Here you can see the arrow where the plane is going to repel. It's not going to let things go through. So anything that comes in the opposite direction is going to be stopped by the plane. So we need to flip it first so it faces the correct direction in the earring direction. And now we need to move the plane so it is closer to the side of the head instead of the center of the head. For that, we can use the location transform and we can displace it in the proper way. The plane is going to be infinite, so you probably don't need to worry about the scale. Wrong direction again, we need negative numbers. Too much, too many units, so let's go down and let's fine tune seeing the viewport. For now it's getting closer, but you can see that the plane is pushing from the start the bone because it is outside already of the range of the box, so it is pushing the box and making the simulation weird. So here we need to be more conservative, go closer to the face. We are getting there. You can see that the plane is already parallel to the side of the head and it's already on the left of the box. So right now you can see that it is almost there. It may be pushing a little bit the box, so we want a little less. And you can see right now that it is working, I think, really well, and it is not going to let the earring go through and make it not clip with the neck or face. You can use this plane also for things to not clip with the ground or something like that if it would like drag. But I'm just trying to make a nice example with the earring. But as I mentioned before, this can be used for lots of other things, like for example a tail that you want to clip the ground with or things like that. Okay, so right now we are almost getting there, but I wanted you to see an example of a complex chain. So in this case, we are simulating two bones. Bear in mind that the longer the chain, the more compute it needs. So if trying to make it light on the CPU and on the machine, adding things to the chain, it's going to make it heavier. The constraint setup is copied, so it keeps the settings that we have, and now you can see that it is a mess. But it is kind of normal because if you remember, we had an spherical limit, which is going to cause problems. I'm changing the left earring because I did not like the simulation as it was. The right one I did like, so I'm not touching it. But here we are going to make it a little more complex to get a better effect. And so you can see longer chains in Anim Dynamics. Let's go ahead and get rid in the second box of the local joint offset on the y-axis. And right now, as I mentioned before, if we don't get rid of those spherical limits, since the sphere is not letting the bodies out, as you could see before, it was already stuck on the side of the sphere, and that's why it was getting turned around. You can see it right there. It in the beginning gets stuck on the side of the sphere and it cannot move. So for now we can adjust the box stands to make them smoother, and maybe try to adjust the local joint offset to keep it the way it was, but the problem is going to stay the same. So as long as we don't remove those spherical limits, it's going to cause trouble. Since we don't want offsets between both of the bodies, we left them at 0, and right now we are going to turn up the angular damping just to make it smoother. Since this is the end of the chain, we don't want it to get too carried away, and we are going to make the box probably a little bigger, so as I mentioned before, the simulation is more stable without having to turn up the iterations, which are costly. Here we turned off the spherical limits, and you can now see the chain working pretty a-okay, but for now I think the limits are not perfect. Let's turn down the angular damping so we get a better effect, and with more rotation it may be too much, but for now we can go ahead and test it and see how it looks. It is not looking bad, but I'm still not satisfied. It is probably due to the fact that we have lots of rotation on the first bone, which is then accumulating with the second one. The result is probably going to be better if we have less limits on the first one and higher limits on the second one, but let's look at it in game and see how it is looking. For now, let's jump. You can see now that it has a lot more forces, but since they don't have a lot of mass, they are still stabilizing way too quickly in my opinion, but it is looking way better. We can improve on that result, as I mentioned before, changing the limits. You can see that if you change the limits on the first bone, it will make it less twitchy. Let's go for -15 and 15 on the Y and Z axis. And with this, the first bone is going to be less twitchy. And the second one, it's still going to keep those -45, 45, which is going to make it curl, which is what you want on a chain like this. So if we now take a look at it in game, you are going to see that the result is way better. Let's go full screen so you can see better the results, but they are looking really great. As you can see, the earring is moving smoothly, even with low mass, and it is working great. If you want to improve a little more, let's go ahead and turn up the solver iterations pre and post update, which is going to make the simulation better. Bear in mind that this turns up the cost, so let's use 2 and 8. Let's not go too overboard, and with that you are even going to get a better result, a more stable simulation, and a better quality simulation. Just bear in mind that it is going to be more costly, so don't go too far with these parameters. Let's go and check the results again. Look how smooth it is right now. It is looking great. Okay, so last but not least, I wanted you to know a small trick that you can use with Anim Dynamics. Let's create a float variable and let's name it Dynamics Alpha. And with that, we are going to be able to control from Blueprint the strength of the effect. Let's get that variable and connect it to the alpha pin in the Anim Dynamics nodes. This is going to allow us to say to the Anim Dynamics nodes how much of the dynamics we want to keep. If we now compile, we are going to be able to adjust the alpha parameter between 0 and 1, being 0 no dynamics and 1 the maximum amount of dynamics. You can read per frame the variable on the event graph of the Anim blueprint. So with that, you can manipulate from your gameplay the dynamics of the character. Let's use 0.1 so you see the effect. Right now we are not going to see much movement on the earrings, and you can see the original in yellow, the original box, and in white the new dynamics. In game you are going to see that they don't look much because we went down to 0.1, so at 10% of the dynamics we are keeping. So as you can see, they are moving, but they are really subtle. So for example, if you know that the character is going to move too much or do some weird things, you can deactivate them and just in that segment of gameplay have less dynamics on your character that can get you out of a pinch. Well, so that's it for this video. As you can see, the Anim Dynamics node is a little difficult to use, but with the tips and tricks that I just gave you, I think you will have no trouble at all. Remember, if this video has been helpful, go ahead, like and subscribe, and we'll see each other in the next videos. Huge shout out and thanks to all my Patreons. As you know, making these videos takes a ton of time and effort, because I research in depth all of the topics that I cover. So if you want me to keep making awesome stuff, consider supporting me on Patreon.